In this section, we're going to look at displaying data and handling events. By the end of this section, you'll be able to display data on your views, apply classes and styles to DOM elements dynamically, format data using pipes, and handle events raised from the DOM elements. So now, let's get started. So earlier, you learned about interpolation. It's the double curly braces syntax we use to display data. So here we have two examples. One is for rendering the title field, and the other is for the image URL. And with this template, we get something like this. Now, this interpolation is just a syntactical sugar. Behind the scene, when Angular compiles our templates, it translates these interpolations into what we call property binding. With property binding, we bind a property of a DOM element, like source here, to a field or a property in our component. Now let me show you the syntax for using property binding. I'm going to rewrite the second example, but instead of using interpolation, I'm going to use property binding. So image, I want to bind the source property. So I put it between square brackets, source, and for the value I use the title field of courses component. Note that here we don't have double curly braces. So when we use double curly braces or string interpolation, Angular behind the scene translates that into the second syntax. And with this, whenever the value of the title field changes, the source attribute of this image element is automatically updated. Now here you might have a question. You might be wondering whether you should use string interpolation or the square bracket syntax. Well, interpolation works well for adding dynamic values between headings, like here between the h2 element, or if you're using divs, spans, paragraphs, or wherever you want to render text. That's when you use string interpolation. In this example, if I want to use property binding with this h2 heading, look what I have to write. So h2, now I have to bind the text content property of h2 DOM element. I have to bind this to the title field of the courses component. Obviously, you can see the second syntax is longer and more noisy. So that's why I prefer to use string interpolation wherever I want to add text between headings, paragraphs, divs, and spans. In other cases, you can see the property binding syntax using the square brackets is actually shorter. Now, there is nothing wrong with using string interpolation here, but the second syntax is cleaner and shorter. Now, the syntax aside, one thing you need to know about property binding is that it works only one way, from component to the DOM. So if these fields in the component change, Angular will update the DOM. But any changes in the DOM are not reflected back in the component. So if we add an input field here, and the user types something in the input field, the underlying property or field in the component will not be updated. We have two-way binding for that, and I will explain that later in this section. So in the last lecture, you learned about property binding. So we put a property between square brackets and then bind it to a field or a property in our TypeScript class. Now let me show you another example. This time I'm going to create a table. Inside this table, we're going to have a row and one column, like this. Now, this time I want to bind this colspan property to, let's say, colspan field in our class. And then I'm going to set this to 2. Save. Now back in the browser, we got a blank page, which means something is not right. So let's take a look at the console. Once again, the shortcut is Shift, Command, and I on Mac, and Shift, Control, I on Windows. All right, look at the error. Can't bind to colspan since it isn't a known property of TD. What's going on here? Well, in order for you to understand this error, first you need to understand the difference between DOM, or Document Object Model, and HTML. DOM is a model of objects that represents the structure of a document. It's essentially a tree of objects in memory. HTML, on the other hand, is a markup language that we use to represent DOM in text. So when your browser parses an HTML document, it creates a tree of objects in memory that we refer to as the DOM. Now, we can also create this tree of objects programmatically using vanilla JavaScript. So we don't necessarily need HTML, but using HTML is far simpler. Now, here's the key thing you need to know. Most of the attributes of HTML elements have a one-to-one mapping to properties of DOM objects. There are, however, a few exceptions. For example, we have HTML attributes that don't have a representation in the DOM. Here, callspan is an example of that. So when we parse this HTML markup and create an actual DOM object for this TD, that DOM object does not have a property called callspan, and that's why we get this error. So callspan is an unknown property of TD. Also, we have properties in DOM that do not have a representation in HTML. For example, earlier I showed you that we can bind to the text content property of H1. This is a property of a DOM object, and in HTML, we don't have such an attribute. Now, when using property binding, you should remember that you're actually binding to a property of a DOM object and not an attribute of an HTML element. Once again, in 99% of the cases, these HTML attributes and DOM properties have a one-to-one mapping, but we have a few exceptions here and there. So here we're dealing with the callspan attribute. If you want to bind this attribute of the TD element, you need a slightly different syntax. So in square brackets, you need to prefix this attribute with attr, which is short for attribute, and then dot. This way, we're telling Angular that we're targeting the callspan attribute of an HTML element, in this case, TD. Back in the browser, we don't have any more errors. One of the common questions I get is, how can we add a library like Bootstrap to our application? Now, if you have never worked with Bootstrap before, it's basically a CSS library that gives your applications a modern look and feel. You can learn about Bootstrap by going to getbootstrap.com. Now, in this lecture, let me show you how to add Bootstrap to our Angular application. First, in the terminal, in the list of bundles, look at this bundle, styles.bundle.js. The size of this bundle is only 10 kilobytes because currently we don't have many styles in our application. So 10 kilobytes. Now in VS Code, open up the terminal using Control and backtick. Use npm to install Bootstrap. So npm install Bootstrap, and we add -- save flag here. What this does is that first it downloads Bootstrap and stores it into Node Modules folder, but the save flag also adds Bootstrap as a dependency in package.json. Let me show you. So first let's execute this command. All right, we got Bootstrap version 3.3.7. Beautiful. Now let's go to package.json. So package.json. In the list of dependencies, look, we have an entry for Bootstrap. And here's the version number, 3.3.7. Now, what is this caret character here? Well, this version consists of 3 numbers, a major number, a minor number, and a patch number. This caret character means we can use the most recent major version. So we can use version 3.4, 3.5, 3.9. But if there is a newer major version like version 4 or version 5, we are not going to install that. We can upgrade to the most recent major version, in this case, version 3. Now, what is the benefit of adding an entry in package.json? Well, when we check our application code into a source control management tool like Git, we are not going to check in the Node Modules folder. So this Node Modules folder includes lots of libraries, and it takes a fair amount of space on the disk. We don't want to check this into a source control repository. So by listing all the dependencies inside package.json, anyone who checks out this code from a source control repository can simply go to the terminal and type npm install. With this, npm looks at package.json and downloads all the dependencies on this machine. Okay? So now we have installed Bootstrap. Next, we need to import its style sheet into our styles.css. So let's go to styles.css. This is where we add all the global styles for our application. Now here we're going to use the CSS import statement. So @import, and we add the path to Bootstrap CSS file relative from node modules folder. So we use tilde again. Inside the node modules folder, we have a folder called Bootstrap. Let me show you. So here's the content of node modules. We've got Bootstrap. Now here we have a folder called dist, which stands for distributable. And inside that we have CSS. Now we need to import this bootstrap.css here. So bootstrap/dist/css/bootstrap.css. Save. Now let's go back to our courses component, courses.component.ts. Here in the template, I want to add a Bootstrap button. So button, and I want to give it two classes. One is btn, that all buttons have, and btn-primary, which makes our button blue. And let's call this save. Okay, now that I saved the changes, let's go back in the terminal. Look at the size of our styles bundle. It's 159 kilobytes. Previously, it was only 10 kilobytes. But now that we imported Bootstrap, we have a lot more styles. Now let's go to the browser. So this is our Bootstrap button. Now, as you can see, this button is too close to the edge of the screen. So back in styles.css, I want to add a style for the body element. Let's add a 20 pixel padding. Save. Back here, that's much better. There are times that we may want to add additional classes to an element based on some condition. For example, here, I may want to apply the active class on this button based on the state of the underlying component. We use a variation of property binding for that. So we start with the property binding syntax. We add the class property here. Now dot, and here we specify the name of the target class, active. Now we bind this to a field or a property in our class, in our component. So let me define a field here, is active, and set this to true. Now I'm going to use this field here, is active. Save. Back to the browser. All right, let's right click this button, inspect it. Look, here we have three classes, btn, btn-primary, and active. If I come back here and change the value of this field to false, save. Now look, the active class is gone. So we refer to this syntax as class binding. If this condition here evaluates to true, this target class will be added to this element. Otherwise, if it's false and this class exists on the element, it will be removed. Also, I want to clarify that I separated this class binding from the actual class attribute because I want to keep these two classes, btn and btn-primary, at all times. I only want to add the active class dynamically based on some condition. We also have style binding, which is again a variation of property binding, very similar to class binding. So back to our example, if I want to apply some inline styles to this button based on some condition, I can type something like this. So we start with the square brackets, now type style, and then we can add any properties of the style object in DOM. For example, we've got background, color. Now for the complete list of all the properties in the style object, you can simply search for DOM, style object, properties. Now if you scroll down here, the first link, HTML, DOM style object on W3 schools, on this page, in this table, you can see all the properties available in the style object. Now back to our example, we set this to an expression. So if isActive is true, we want the background color to be blue. And note that here I'm putting blue between single quotes. Otherwise, I want the background color to be white. So this is what we call style binding. All right, so far you have learned about property binding and its variations like class binding, style binding, and attribute binding to add something in the DOM to display data. In Angular, we also have event binding, which we use to handle events raised from the DOM, like keystrokes, mouse movements, clicks, and so on. So here we have a simple button, and we want to handle the click event of this button. So instead of square brackets, we use parentheses, and here we add the name of the event, like click. Then we bind this to a method in our component. So let's call this onSave. Now here I create this method onSave and simply log a message in the console. So console.log button was clicked. Let's try it. So here's our button, click. Now let's take a look at the console. Okay, here's the message. Now sometimes we need to get access to the event object that was raised in the event handler. For example, with mouse movements, the event object will tell us the X and Y position. If you want to get access to that event object, we need to add that as a parameter here. So $event, and then when calling this method, you also pass $event. This $event object is something known to Angular. Now, in this case, we're dealing with a DOM object, that's the button. So this $event object will represent a DOM event, a standard DOM event that you have seen in vanilla JavaScript and jQuery. Later, I will show you how to create custom components. And there, this $event object will represent a custom event that you define in your application. So back in our onSave method, let's log this event, $event, save, back in the browser. So one more time, click. Okay, here's our $event object. All these properties you see here are part of the standard DOM event objects. So we have the movement X and Y, offset X and Y, and many other properties. Now, all the DOM events bubble up the DOM tree unless a handler along the way prevents further bubbling. This is just a standard event propagation mechanism in DOM, and it's nothing specific about Angular. For example, let me wrap this button with a div like this. Now in this div, I also want to handle the click event. So parentheses, click, and I want to bind this to a different method. So let's call this onDivClicked. So let's add this method here, onDivClicked. And here I want to log a different message. Div was clicked. Now let's see what happens. So when we click this button, we get two messages in the console. The first one is the handler for the click event of the button, and the second is from the handler of the click event of the div. So this is what we call event bubbling. An event bubbles up the DOM tree. So to extend this example, if we had another div or another element that contained this div, and we handle the click event on that element, our event object will bubble up and hit that target handler. Now, how can we stop event bubbling? Well, here in onSave, we can call $event.stopPropagation. Again, this is a standard method you have seen before in vanilla JavaScript. So when we call this, this event will not bubble up. In other words, it's not going to hit the second handler. Let's try it. Save. Back in the browser. Click. Now look, in the console, we only have one message that's coming from the handler of the click event of the button. In Angular, we have this concept called event filtering. So here we have an input. Let's say we want to handle the key up event. So parenthesis, key up, and we bind this to a method called onKeyUp. Now let's pass the event object here, $event, and then create this method in our component, onKeyUp, that takes an event object. Now here, let's say we want to submit the form or perform some action only if the user presses enter. So this is the traditional way of implementing this. If $event.keyCode equals 13, which represents enter, then we can do a console log, enter was pressed. Let's try this. So here I'm going to type a few characters and then press enter. Now in the console, we should have only one message. Okay, enter was pressed. Beautiful. Now in Angular, we have a better way to implement the exact same feature. So we can apply a filter when handling an event. So here, when handling the keyUp event, we can add .enter. So this onKeyUp method will be called only if we press the enter. And with this, we don't have to pass this event object here. We don't have to add this parameter here, and we don't have to write this ugly code with this magic number 13. This is much cleaner. Let's try it. So once again, I'm going to type a few characters, enter, and here in the console, we have enter was pressed. All right, continuing from our last example, let's imagine we want to get the value that was typed into this input field. How can we do this? There are two ways. One way is to use the event object. So once again, we pass this event object here, add this parameter to our method, and I'm going to remove this message and simply log $event. Now this is a standard event object in DOM, so it has a target property that references this input field. And from here, we can get the value. Let's try this back in the browser. So if I type Angular and press enter, now in the console, we have Angular. Beautiful. Now in Angular, we have another way to solve the same problem. Instead of passing this event object around, we can declare a variable in our template that references this input field. So here I declare a variable like this. Let's imagine this input field is for capturing the user's email. So I declare a variable using this hashtag or the $, and this is the name of our variable. We call this a template variable, and this references this input field. Now, instead of passing this event object around, we can pass email.value. Okay, and then as the parameter to this method, we can simply receive the actual email address and log in on the console like this. Let's try it. So me@example.com. Enter. And here in the console, we got the email address. So in a lot of cases, you can use template variables to simplify your code. Now this code that we wrote in the last lecture, it works, but we could do better. What I don't like about this implementation is passing this email parameter or argument around. In object-oriented languages, where we have the concept of objects, we shouldn't really pass parameters around, because an object encapsulates some data and some behavior. So if an object or a class has all the data it needs, we don't have to pass parameters around. This kind of code we have here is what we refer to as procedural programming. That's the kind of code we used to write 30 years ago before we had object-oriented programming languages. So imagine if we had a field here called email. Then we wouldn't have to pass this email around. And here we could simply log this.email. So you can see our method has no parameters. And this is cleaner, easier to read, easier to understand, and easier to maintain. Also, going back to the definition of a component in Angular, remember, a component encapsulates the data, the logic, and the HTML markup behind a view. Here, the email field is used to encapsulate the data, and the onKeyUp method represents the behavior or the logic behind this view. And of course, here's our HTML template. Now, how do we get here? Well, first of all, we don't need this template variable anymore. So delete. Also, we're not going to pass that here. So our code is a little bit cleaner now. Now, earlier you learned about property binding. So we can bind the value property of this input object in the DOM to this email field, right? And now if I initialize this to, let's say, me@example.com, when we load this page, the input field should be populated with this email address. So look, we've got me@example.com. However, if I change this to domain.com and press enter, now in the console, look, we got me@example.com. So how come we didn't get me@domain.com? Because with property binding, the direction of binding is from the component to the view. So if the value of this email field changes at some point in the future, the view will be notified and this input field will be automatically updated. Now what we need here is a slightly different kind of binding. We want a binding that works in two ways, from component to the view and from the view to the component. So if we type something in the input box, we want this email field to be updated. Let me show you one way to implement this. And of course, this is not the best way, but I'm going to show you a better way in just a few seconds. So with this value property binding, we have one direction from component to the view. For the other direction, we can modify this expression here. So instead of directly calling the onKeyUp method, first we can set email to $event.target.value, then semicolon, and then call the onKeyUp method. So what I want you to pay attention to here is that for the value of event binding, you can write any expression. So here we have two statements, one for setting the email field and the other to call the onKeyUp method. Now let's try this code. Save, back in the browser. So we've got me@example.com and I'm going to change this to domain.com. Now enter. Look, in the console, we got me@domain.com. Beautiful. So with this implementation, we have two-way binding. But as you can imagine, this is the kind of feature that we may need frequently in a lot of applications. We don't want to write all this repetitive code. Is there a better way? Of course there is. In Angular, we have a special syntax for implementing two-way binding. So let me duplicate this line so you can see the difference. Instead of using property binding on the value property, we use the two-way binding syntax, which includes square brackets and parentheses. Now, if this syntax is complicated or you may forget it, I give you a tip. This is called banana in a box. So this is a banana and this is a box. So banana in a box. Now, instead of value, we bind to ng model. What is this? Well, our DOM objects, our input DOM object doesn't have a property called ng model. So this is something that Angular adds to this DOM object. Now earlier you saw ng4. Remember, ng4 is a directive and we use directives to manipulate the DOM. So in Angular, we have another built-in directive called ngModel that is used for implementing two-way binding. So this implementation we have here is encapsulated in a generic way inside a directive called ngModel. And with this, we don't have to repeat this code every time. So then we can simplify this expression. We can delete this statement. And in keyup.enter, we simply call the onKeyUp method. Now look, the second line is obviously cleaner, shorter, and easier to understand. So here's the lesson. Whenever you want to use two-way binding, use the banana in a box syntax and bind to the ngModel property. Now let's try this. Save. All right, we got this error. Can't bind to ngModel since it isn't a known property of input. That's a familiar error, isn't it? So basically, our input object doesn't have a property called ngModel. It's something that Angular adds here. But why are we getting this error? Angular framework consists of several different modules. In every module, we have a bunch of building blocks that are highly related. We have components, directives, and pipes, and these are highly related. Now, not every application needs all the modules in Angular, because when you bring all these modules, you increase the code size. So this ng-model directive is defined in one of the modules called forms. And by default, this is not imported into your application. So if you want to use ng-model, or if you want to build any kind of form, you need to explicitly import this module. How do we do that? Very easy. So let's go to app module. With Command and P or Control P, we go to app.module. Now look at this ng-module decorator. Here we have a property called imports that is set to an array. In this array, we have browser module. Browser module is one of the built-in modules of Angular, and it brings some features that almost every browser application needs. Now here we need to add another module, the forms module. So on the top, so look, this is where we are importing the browser module. Let's import forms module from @angular/forms. So that's defined in this library. And then we can import it into our main app module. So forms module. Save. Back in the browser. All right, we've got me@example.com, and then I'm going to change this to domain.com. Enter. Look at the console. And here's me@domain.com. Beautiful. Another building block in Angular is pipe. We use pipes to format data. For example, we have a bunch of built-in pipes like uppercase, lowercase, decimal, currency, and %. We can also create custom pipes, which I'm going to show you in the next lecture. So let's see these built-in pipes in action. So here in this component, I have defined a course object with these properties: title, rating, students, price, and release date. And in the template, I'm simply rendering these properties on the view. Now I want to show you how we can use pipes to format the data. So starting from the title, let's say we want to display this as uppercase. First, we apply the pipe operator, which is a vertical line, and then the name of the pipe, uppercase. Back in the browser. Okay, look, here's our title displayed in uppercase. We can also chain multiple pipes here. So I can get the result of this expression and flow it through another pipe. In this case, lowercase. And guess what? The title is going to be lowercase, okay? So pretty simple. Now look at the number of students. Here we have 5 digits, but to make it more readable, we can apply the decimal pipe to separate every 3 digits using a comma. So here, I'm going to apply the decimal pipe. Now the keyword for this decimal pipe is number, even though the actual class in Angular is called decimal pipe. Now let's have a look at the result. Now look at the number of students. Look, we have a comma here, which makes it more readable. Next is the rating. Now with this number or decimal pipe, we have control over the number of integer digits, as well as the number of digits after the decimal point. So here we have applied the number pipe or the decimal pipe to the rating property. Now to have more control over the number of integer and decimal point digits, we supply an argument here. So colon, and here we put the argument in a string. Now the first number we supply here is the number of integer digits. So let's say 1. Now dot, and then we supply the minimum and maximum number of digits after the decimal point. So our rating, look, it has 4 digits after the decimal point. If I want to display only 2 digits after the decimal point, I would add 2-2. So 2 as the minimum and also as the maximum number of digits after the decimal point. Save. All right, look, we've got 4.97. Now look what happens if I change this to 1-1. So I want to have only 1 digit after the decimal point. Look at what we got. So our rating is now rounded, 5.0. Also, if I change the number of integer digits from 1 to 2, look at what happens. Now we have a leading 0 here. So these are the kind of things you can do with the decimal pipe. Next, we have the price. We can use the currency pipe to format this as a price. So here's the price property. Apply the pipe operator and type currency. Save. Now look, by default, we get US dollars. Now I can change this to, let's say, Australian dollars. So once again, we supply an argument, colon, put a string here, and the name of the currency is Australian dollars, AUD. Save. And here we get Aussie dollars. Now some pipes, like the currency pipe, can take multiple arguments. So here I can supply another argument, once again, colon, true, to indicate that I want to display the currency symbol. Let's look at the result. So instead of AUD, we get a dollar sign. And finally, optionally, I can supply the third argument. So once again, colon, string. And here we supply a string similar to the string we supplied to the decimal pipe. So I want to have minimum 3 integer digits with 2 digits after the decimal point. Now, this is not going to make any differences here, but I want you to be aware of all the arguments that we can supply to the currency pipe. And finally, we've got release date, which is rendered like this. Now, it's not very readable for humans, so let's apply the date pipe. Once again, pipe operator, date. Now we want to supply a format. So colon, string. Let's format it as a short date. Save. Back to the browser. This is what we get. Now, if you want to see all the formats available to you, head over to angular.io, and in this search box, search for date pipe. So here's the date pipe class. Note that this is defined in @angular/common library that you can install using npm. Our project has this by default, and it's defined in this module, common module. You haven't seen common module before, you have only seen the browser module. But when you import browser module, it also brings in the common module. Common module has a bunch of artifacts that all applications, whether they're browser applications or not, require. Example of that is this date pipe. So if you scroll down on this page, here you can see all the formats available to you, like full date, long date, medium date, and so on. And below that, there is more detail in this table. Now in Angular 1, we had 2 pipes, or 2 filters more accurately, for sorting and filtering data. In Angular 2, we don't have these, and this is not an oversight, it's for deliberate reasons, because these filters, or these pipes in Angular terms, are expensive operations. So Angular team decided to drop these filters in Angular 2 and onwards. Next, I'm going to show you how to create a custom pipe. All right, now let me show you how to implement a custom pipe. So here I have this text field that is set to a really long text, as you can see here. And then in the template, I simply want to render this text, but I want to summarize it. In a lot of websites, in a lot of blogs, you can see the summary of recent posts on the homepage. So here, we can implement a custom pipe to summarize this text, and then use it like this: pipe, summary. So let's see how we can implement this custom pipe. So we go in the app folder, add a new file, and call it summary.pipe.ts. The same convention we have used when creating components and services. Now here we need to import a couple of types from Angular. One is the pipe decorator function, and the other is pipe transform, which is an interface that defines the shape of all pipes in Angular. Now we need to import these from Angular/core. Then, just like components and services, we export a TypeScript class. Let's call this summary pipe. And here we need to implement this pipe transform interface. So implements pipe transform. Now, what is this implement? With this, we're telling TypeScript compiler that this class should have the exact same shape as the pipe transform interface. And that's why we have this compilation error. Let's take a look. So class summary pipe incorrectly implements interface pipe transform. Now, if you head over to angular.io and search for pipe transform, look, you can see that here it's an interface. If you scroll down, this is how this interface is defined in Angular. So in this interface, we have one method called transform with the signature. Our custom class should have a method with the exact same signature. So here I'm going to add a method called transform. This method should have two parameters. One is value, which can be anything, and the other is args, or the arguments we supply to our custom pipe, which is an optional parameter, and that's how we specify it in TypeScript using a question mark. And again, the type of this parameter is any. You can see the compilation error is gone. Now finally, we need to apply the pipe decorator function here. We pass an object. This object should have a name property. And here we add the keyword that we want to use in our HTML markup. So I use summary here because in our markup, we use summary as the name of the pipe. Now back in our pipe class, let's implement a very basic summarizing algorithm. So first I want to do some basic validation. If this value is falsy, I'm going to return null. So if it's null, an empty string, or undefined, we're simply going to return null. Otherwise, we're going to summarize it. So to get IntelliSense here, I'm going to change the type of the first parameter from any to string. And now we can type value dot, and we get all the methods available in the string class. We're going to use substring. So starting from the first character, we want to get a maximum of, let's say, 50 characters. And then simply return that. Now to make this a little bit more readable, we can also append ... at the end. Now if you go to the browser, we have a blank page, which means something is wrong. So in the console, the pipe summary could not be found. Because we defined this custom class, but we forgot to register this in our app module. Just like components or services, if you use a component without registering it in a module, Angular doesn't know about that component. The same applies to pipes. So let's go to app.module. Here in the declarations array, we add all the components and pipes that are part of this module. So I'm going to add summary pipe. And obviously my auto import plugin automatically imports the summary pipe on the top. Okay, save. All right, this is what we get. So you can see we have only the first 50 characters with ... at the end. All right, now let's take this to the next level. Back in our component, I want to be able to supply an argument here. So colon, I want to set the number of characters that I want to be included in the summary. Let's say 10. So to implement this, let's go to our summary pipe. So to make this more readable, I'm going to change the name of this parameter from args to limit. And I'm going to change its type to number. So then I'm going to write some code like this. Let define an actual limit. Now, if we have a limit here, we're going to use that value. Otherwise, we're going to use 50 as the default limit. And then pass actual limit here. Let's try this. Back in the browser. Now we have only the first 10 characters. What if we had multiple parameters here? We could simply add additional parameters. Let's say another, and that's going to be optional. It could be a Boolean, it could be a string, it could be a number, whatever, depending on the type of custom pipe you're going to implement. So in this case, we don't need this. Let's make it simple. All right, now I want you to use what you have learned in this section and implement a favorite component like what you see here. So when we click this, it becomes full. And when we click again, it becomes empty. You have seen something like this on a lot of websites. One example is Stack Overflow. Look, next to each post, we have the star icon. So we can implement this as a reusable component in Angular. Now, how do we render a star icon? For that, we're going to use Bootstrap. So if you head over to getbootstrap.com and then go to the components page, scroll down, look, these are all kinds of icons that you can render with Bootstrap. Below each icon, you see two classes, glyph icon and glyph icon -star. So you simply need a span element with these two classes, and then you get the exact same icon. Now in this case, you want to render this glyph icon -star or glyph icon -star-empty depending on the state of the component. So we need to render these classes dynamically. And that's the whole purpose of this exercise. So go ahead, implement this component, and then you can see my solution. All right, I'm going to start by creating a new component using Angular CLI. So let's go to the terminal, ng, g, what's next? C for component, and then favorite is the name of our component. Beautiful. Now let's go to the template for this component, that is favorite.component.html. So favorite.html. Okay, I'm going to delete this markup and render a simple star icon using Bootstrap. So a span element, and here I'm going to add a couple of classes. One is glyph icon, and the other is glyph icon -star. For now, I just want to render a static star icon. I don't worry about implementing any behavior here. I just want to make sure everything works up to this point. So now let's go to app.html and use our new component. So I'm going to delete all this markup and add app-favorite, which is the selector for this new component. Now here, app- is a little bit of noise. And because this is a small application, we're not going to use any third-party components. So the chances of this element clashing with another element defined somewhere else is very, very low. It's literally impossible. So I would prefer to make my code cleaner. Let's go to favorite.component.ts and change the selector here. Remove app-. Make it simpler. Now back in the template, for app.component, we can also simplify this and use favorite. That's better. Now let's test this up to this point. Back in the browser. Okay, we got a full star icon. Beautiful. Now we need to add behavior to this. So back in our component, here we need to keep the state, the data behind this view. What is that data? That's the state of this icon. Or in other words, the object this favorite icon is for, whether that object is selected as favorite or not. So here I can declare a field, call it isFavorite, and we can initially set this to false, or we can use type annotation and set its type to Boolean. Again, it's going to be false, so it doesn't really matter which approach you choose. Now, in a real-world scenario, you only get this state from the server. So we call a RESTful endpoint. We get a list of objects like a list of Stack Overflow posts. And for each post, we know whether the current user has selected that post as favorite or not. But in this exercise, we don't want to worry about calling the server. So we're just going to focus on the user interface. So here's our field. We also need a method to toggle this field. So let's define a new method here. OnClick. So this is going to get called when the user clicks this icon. And here we simply set this that is favorite to not this that is favorite. So we're simply toggling this field. If it's true, it becomes false. And if it's false, it becomes true. Now let's go back to our template. So all icons should have this glyph icon class. But this second class, we want to render this dynamically based on the state of the component. So I'm going to delete this here and also break this into multiple lines so we can see more clearly. Now to add additional classes, I'm going to use class binding. So square brackets, class dot glyph icon dash star. We want to render this only if isFavorite is true. So we can bind this to isFavorite field. Okay. Now, similarly, I'm going to apply another class binding here. So class.glyph icon, but this time dash star dash empty. And we want to render this class only if isFavorite is false. So we can bind this to isFavorite, but apply the not operator here. So when this expression evaluates to true, which means when isFavorite is false, then we're going to get this empty star icon. Okay. Now finally, we're going to handle the click event. And here we simply call onClick method. Let's test this. So back in the browser. So our star is initially empty. If we click it, it becomes full. If we click again, it becomes empty. I hope your solution was the same. If not, as long as it works and it's clean, that's perfectly fine. Now it's time for another exercise. So look at this application. In this input field, I can type the title of a movie or a course or anything, and you will see that title converted to the proper title case format. So let's say The Rise of the Planet of the Apes. Note that here we have two prepositions, the and of. These prepositions should always be lowercase unless they are the first word of the title. And apart from these, all the other words, their first letter should be capitalized. This is what we call title case. So I want you to use what you have learned in this section and implement a page like this. And by the way, if I type everything in capital, The Rise of the Planet of the Apes, see, we still get the proper title case format. Or I can mix the uppercase and lowercase. So The Rise of the Planet of the Apes. And the application is still working. So as you're building this, make sure that all these edge cases work properly. Next, you can see my solution. All right, I'm going to solve this problem in 2 steps. First, I'm going to add an input field and echo whatever the user types in that input field without applying the title casing. If that part works, then we'll move on to the next step. So here in app-component.html, I'm going to add an input and use two-way binding syntax. Remember banana in a box? So we bind ngModel to the title field of our app component. So let's go to app component, declare this field title, and it's a string. Now back in app-component.html, below that, I'm going to add a br, a break, and use interpolation to echo what the user types in the input field. Let's test the application. So The Rise of the Planet. Okay, that's working. Beautiful. So now let's implement the title casing. For that, I want to build a custom pipe that we can use like this. Title case. So let's open up the terminal and use Angular CLI to generate a new pipe. So ng g p, short for pipe, and we're going to call this title dash case. Okay, beautiful. Now let's go to title case.ts. Okay, here's our pipe. So you can see the name of the pipe is title case. That's good. Now let's implement this transform method. I'm going to simplify this by changing the type of this value from any to string, so we get compile time checking and IntelliSense. And we don't need this second parameter because we're not going to send any arguments to this pipe. So here first we want to do some basic validation. If this value is falsy, we're simply going to return null. Otherwise, we need to break this string, get all the words, and write some logic to determine if that word should be in the title case or lowercase. So I'm going to declare a variable, words, and set it to value.split. We want to split by a space. Then we need to iterate over these words. So for var index, we set it to 0. As long as it's less than words.length, we want to increment this. Oops, I made a mistake here. So that should be index. Or to make the code cleaner, we can simply use I. Now, for each word, we want to see if that word is a preposition or not. So first, I want to declare an array to hold the list of prepositions. Let prepositions, we set it to an array. Now, there are more than 40 prepositions in English. We don't need all of them here for this exercise. So I'm going to add only the two that we need, of and the. So now for each word, we need to write some logic like this. If words of I, we want to see if it's preposition or not. So we need to see if this word exists in our prepositions array. So if prepositions includes this word, then we want to make sure that it's lowercase. So words of I, we set this to words of I dot to lowercase. Otherwise, we want to apply the title casing on this word. So words of I, we get this. We want to get the first character, so substring from 0 to 1, and then make this uppercase. And then we want to get words of I, the substring from the second character onwards, and make sure this is lowercase. Now finally, we need to store the result in words of I. Now after this iteration, we want to combine all these words using a space and return it to the consumer of this pipe. So return words.join. We want to join them with a space. Let's test the application up to this point. So the rise of the planet of the apes. It's almost working, except that when a preposition is at the beginning of the title, when it's the first word, we still need to apply the title casing there. So I'm going to change this second if condition to if I is greater than 0, which means it's the second word or after that, and then it should definitely be in lowercase. Let's test the application. So one more time, the rise of the planet of the apes. This is working perfectly. Now, how about the rise of the planet of apes all in uppercase? Well, you can see that all our prepositions like of and the now are in title case. So back here, where we are checking to see if this word is a preposition, we need to apply two lowercase here, because in our prepositions array, all the prepositions are in lowercase. Save. So one more time, the rise of the planet of the apes in capital, working beautifully. And let's try one weird combination. The rise of the planet of the apes. Still working, perfect. So this is how we implement this pipe. But I don't quite like this code. It's a little bit too busy. It's easy for me to read and understand this code because I'm the author of this code. But someone else looking at this code, they have to figure out what is happening with all this for, if, else, to lowercase, to uppercase. It's just too complicated. So let's refactor this step by step. The first issue I see here is on line 18, where we're checking to see if this word is in the list of prepositions or not. So we're calling this to lowercase here, and then the includes method of the array. We can encapsulate all this inside a separate method. In terms of the cohesion, look, we have declared this array here, prepositions, and used it only on line 18. So we can move all this code into a simple method like is preposition. Let me show you. So I'm going to declare a private method because I don't want the consumer of this method to call this from the outside. It's purely for the internal use of this title case pipe class. So is preposition. It takes a word, which is a string, and returns a Boolean. Now I'm going to move our prepositions array there, and this simplifies and cleans up our transform method. See? Imagine if we had 40 prepositions here. that would completely pollute the implementation of the transform method. So let's move this into this new method, is preposition. And also I'm going to move this logic here into our new method and instead call this that is preposition and give it word of I. See, this is much cleaner. So now let's paste this logic here. So we want to return prepositions that includes. Now instead of words of I, we want to work with word, which is the argument to this method. So we have a simple method with only a few lines of code doing only one thing. Now similarly, we can get this complex logic where we're getting the first character, making that uppercase, and then appending the other characters in lowercase. We can extract this logic and put it into a separate method like toTitleCase. And then potentially we can reuse this somewhere else. So once again, I'm going to define a private method toTitleCase. Takes a word, which is a string, and also returns a string. And then I'm going to get all this logic here, cut, and paste it into this new method. Return. Now instead of words of I, we want to work with word. And let's change this as well. Okay. A simple method, only one line of code doing one thing. So in our else block, we can call this the toTitleCase and give it words of I. And also we don't need these curly braces here, so let's get rid of them. I left a semicolon here, delete. All right, now let's take a look at our transform method. It's less than 10 lines of code. It's reasonably clean. The only other thing I want to improve here is that we have so many references of words of I. All these square brackets are creating noise in the code. I would rather declare a variable like word and set it to words of I. And then we don't have to repeat all these square brackets several times in this method. Like this. Note that we're going to keep this words of I here because we are modifying our word array. So this is one way to implement this title casing. Now, if your solution was different, don't worry. As long as it's clean, readable, and maintainable, that's perfectly fine. Your code doesn't have to look exactly like my code. In fact, it's impossible. So don't set that as a standard.